Welcome back to part 2 of the budget build video guide series, where if you've been following along, you have your fully operational rig. And we're going to go from our fresh Linux Mint install to having everything fully set up and operational. And so the first thing that we're going to actually need to do, because this is the brand new fresh install that you guys had too, is get an actual screen recorder, because your viewing experience is really going to benefit from this. Once we've got this set up, I will switch over and we're going to run an install script that I've prepared in advance. And I'm going to walk through every single part of it with you, of course, because you should not be running any scripts that are coming from third parties without knowing exactly what they do. So we're going to jump straight into getting set up, because if you've come from the last video, then you're going to have this screen and you shouldn't have anything else set up. So first thing to note is that you do need an internet connection. We are using Ethernet, but set up your Wi-Fi if you so choose. So let's go. Now colors, we did want to set up in the last video. System snapshots, again, last video too. This is your backups, set it up if you want. More importantly is going to be the driver manager, as well as our update manager. Now our script will actually take care of the drivers for you. It's designed to basically be run on any sort of hardware, just right off the bat. But we'll go through it here because this is the traditional pathway. Now, a lot of these steps can take some time to actually go through, looking for the drivers, download the drivers, apply the drivers. It may also trigger a reset. So if we do need to restart the computer, what we'll do is we'll just cut the video, come straight back. We won't touch anything else at all. This video will be so you can follow along one-to-one. Now, oh, happy days. Bit of a surprise, but okay. Multimedia codecs, I believe we did this in the original install as well. But again, we're just going to go through it and we're going to see what we need. Okay, we have some, most likely because we didn't have internet when we first installed. So just quickly check, we're going to click through. Yeah, it's fine, you just can work it out. I'm going to change the password anyway. So if you slow it down and work out my password, not too worried about it. If you do work out the password, you'll work out the name of my cat. So I'm just waiting for this to go and we'll move on to the update. Now, updates more to do with the operating system, some software that you use. It's not really mandatory. The driver's really, the GPU driver, I should say, is really the most important part. We're going to go through this because the budget build is to be a local AI workstation as well as an active PC that you can use as well. So if you do want to do that, I'd recommend you keep it up to date at all times. So you can go through, you can check everything again. I'm going to hit install all, but if you're so inclined, just go through the list, see what you want, see what you don't. If you have a specific list of things that you know you don't want, again, you don't need me telling you. So just go through this as standard. If you're not sure, install everything or skip it entirely. So I'm just looking at this install and we can see 1.4 gigs and that may take a little bit. So for the purposes of brevity, we will cue a time lapse. So that is us fully updated now. We will move on to the next part. So updates done, system settings. So have a look through this in your own time. There's quite a bit. Some online guides. If you know or have something in mind that you need to change, have a look. The names are pretty good. We'll not spend too much time. Software manager. This is where you download any sort of apps, software, anything like that. The first time you load it, there will be a sort of cache loading, I believe it's called. It'll take a while. Once it's up, you can get pretty much most things you'd be familiar with. And this is where we got the screen recorder from. And then firewall. So our script will take care of the firewall. We need to open it up just to expose the model onto your local network. But again, you can come in here, learn a bit more, customize it some more. So all going well. You're now fully set up on Linux. And in fact, this is your desktop fully ready to go. You don't need AI rig, of course. This is it. This is basically your first Linux. So we're going to go on now to running the install script. We're going to install it, run through it quickly. I'll show you everything and then we'll break it down a wee bit more because there's getting started, which will be very quick. Run it, configure it, go through the steps. But then there's what is it actually doing? which we of course should be going into. So I'm just open up a browser and I'm going to go directly to my GitHub where I've made this public. I'll put links of course down in the description. I don't have that benefit though, so I have to click through the old-fashioned way. Let's come in. So this will be the repository where we keep any sort of documents. Now, just making sure it's up to date. It is indeed. I'm going to add a lot more guides here as well. So if you're ever unsure at any point, come here. You'll be able to find what you want. The original bomb guide is in here for part 1. And any sort of guides, documentation will go in here. There's some more to come, still in work. A manual for the script, things like that. But what we're interested in here is specifically these scripts. So there's a few ways you can do it. You could just download the entire repo. If you plan on staying up to date, download the whole thing, maybe clone it. Or you can come in, I believe it's actually into the file here, and download raw, is it? Download. So you can just download them individually. And so that's our install. Very quickly, you'll see I've commented a lot of this, but that is for another time. And the uninstall, quite simply, name does what it says in the tin. This is just to clear off everything that we're going to set up, and we'll go through this. So we've downloaded our models. I'm going to just close this out. I'm going to show you. In here, you see downloads. Now, put them where you want. I'm going to go into documents and very quickly just make scripts in my documents. You can put this anywhere, of course. In fact, I'm going to change my mind where I've put this into scripts, but we're actually just going to put it at the very root. And what this means is that when we open our terminal, we are at the root. So you'll see here, we have our scripts folder. So we're going to go back to the repository. I'm going to go back, and we're at the home. So this is just the home of the repo. And if you come down here, it's going to give you a little quick start. Again, I'll be providing a more in-depth guide to go through this. But for now, this is just to get us started, get us up and running. So the first thing that you can do, if you just copy this, Control-C. Now, I'll come in here and click, so that's just right-click, paste. Oh, well, that is embarrassing. And it's because I titled it with a capital S. So, we do not hide our mistakes on this channel. What we need to do, in my instance, is make sure that we actually get the path correct. And less is simply going to output some of this here so you can read through it. It's not going to run anything. It's simply going to output the file. Now, you can read it in the browser. You can read it here. Always read it or get familiar. I'll be honest, I don't read a lot of the scripts I run, but that's because they come from trusted sources. So if you Control-Z, Control-D should work as well. That'll get you out. And if you ever just want to clear it, type clear. You can Control-L, but type clear, and that'll be your command to clear the terminal. So I'm going to assume you're going to read through this fully. You're not going to blindly trust me, or you're going to skip through. And what we're going to want to do is run it interactively. Now, we're not going to make the same mistake we did before. What I need to do is update the path, and I'll explain briefly what's going to happen. So sudo simply gives full admin permissions, may prompt you for your password. Bash tells it to run this script using bash, sort of like Python, run this Python script. And then this is the script we want to run. And what this is going to do very quickly is it's going to set up all the GPU drivers that you need. So in our instance, we have an AMD card, but you could be running NVIDIA, you could be running Intel, or you could have just, well, MLX for bare Apple, or you could even have just CPU. This will handle all of it. We're going to auto detect it. Now, if you're going to do this manually, you're going to need to have some knowledge, install the right drivers, know what will work with your hardware. This script is designed to take care of all of that. So effectively run the script, configure it, as you'll see in a moment, and it'll just work. So we're going to go through that. The output software you're going to get, there's three main components. So for GPU monitoring and control, because a big part of this project is going to be about minimizing the cost and minimizing the power is a big part of that, we're going to use an open source program called LACT, L-A-C-T. I'll show you more later. That will give you a UI interface and a programmatic way to actually change the hardware across all hardware. So we'll go into more detail in other videos. There is NVIDIA specific or AMD specific software you can use, APIs. An all-in-one solution is better for this project in the long term, so we went with LACT. For inference, which is running the model itself, so sending an input prompt, getting a response back, you need an inference engine. We're going to be using llama.cpp, same engine that OLlama is built upon. Reason being just performance, configurability, and it sort of just works. So I like it, we're going to work with it. And then how are you going to interact with it? Because if you are a programmer or you have a Hermes agent model, sort of OpenClaw, you have a framework or a layer to work with already. If this is your first time getting started, how do you actually talk to it? Well, we're going to use Odysseus, and this is the open source project produced by PewDiePie, of all people. He's done quite a good job, and it's really simple to get started, and that'll allow you to interact with the models running locally. There is a lot you can use. llama.cpp will have its own UI. We're going to eventually touch upon a program called Uninstall, which has some training and inference options. But for this, we're going to keep it very simple and just the bare minimum to get started. So let's get straight into the script now. So we're going to run it. You're going to enter your password without revealing it. And you're going to immediately be greeted by some text. The theme on this is you're going to be walked through this process. So brief explanation of what it does. And again, I want to reinforce, never run a script from the internet, ours included, without looking at it first. It's just good practice. You don't know what this script will do. And because it's going to be running on the hardware at kernel level, I believe that's the right terminology, it could be doing anything. And bash scripts, the language isn't the easiest to read. So you do want to make sure you go through it meticulously. AI agents are going to be your friend. Copy the script, put it into ChatGPT, ask it what it does. Is there anything malicious? What does this do? This is what the person's told me it will do. Is it correct? Just check you can trust the source. Now, happy that you know what the script does and are you ready to go? Our default is no. So if you're just bashing your way through here, you're going to get kicked out. I need you to confirm this. And so automatically you see we're detecting your GPU, and this has correctly ascertained we are indeed running AMD. Happy days. llama.cpp, great. We're going to deploy this on port 8020. This is the default context window. More videos will come later about how to tweak it. If you know you want more, you don't need me to tell you. Models dir. This is the directory in which we're going to save all of our downloaded models. We don't want to download the same model multiple times. Pointless. We're also running unlimited space on our test bench. And this is just where they're going to go. For this download in the Express, we have two small Gemma models. There is some more options, and later I'll show you how any model you want, really. But this is just to keep the download speed, or the download size small so that the speed is fast. Odysseus, we've got it turned on. It'll be on port 7000. LACT tuning by default. This is to control the power management of the GPU. Firewall, this is to open everything up. On your network, I should say, not externally, simply just so on another PC you can access your AI rig interfaces. Now, I still recommend read through it, do not take my word for it. I would be telling you the exact same thing even if I put a malicious script in here. So, what you can do, however, is skip certain elements. Let's say, for example, you don't want LACT. Or, more importantly, what I would actually recommend you do is customize values first. So we're going to just do C. Now, if you're happy, you could just hit enter. The standard path, what I'd recommend is just hit enter once you're happy. But we will go in and customize just to show. So our model server, this is where our inference is going to be served from. So if you were pointing you're a different agent framework, or you had something else that wanted API access, it's on this port on your network. We're going to keep it default. Odysseus, again, 7000. If you did want to change it, should add, of course, just type in. Now, that didn't work for me. I used the wrong key. But just enter in here. Context window, again, I would just leave this as standard for the small models. If you know you need more, feel free. You don't need to ask me. But again, this depends on the model, depends on your hardware. We'll have separate videos later going more into this. 16,000 should be more than enough for basic tasks. Model tier, we're just going to keep it express. Full at the minute just gives you two more. The Gemma 12 billion and the 31 billion dents. We want Odysseus, and we want LACT, and we do want the firewall. So again, you'll see we're pretty much back here. If we'd changed anything, this would have updated, but we're happy. So what we're going to do is we're just going to hit enter. This does take some time. It may restart. If the GPU driver isn't up to date, you may need to reboot, come back. We're going to basically cue a time lapse now. If there's anything interesting, any interactivity, I will pause, come back. And if you do suddenly see a cut, it's because we had to reboot. So let's get this started. And we can breathe the sigh of relief now that we can see it running. There was a brief moment there where nothing happened. And I have tested this on my NVIDIA rig for context. This is the first run on AMD, so if we have any problems, you're going to see them live as well. And let's have a look. Fantastic. Yeah. So I'm going to scroll up a wee bit here just very quickly to show you. No vendor toolkit needed. Vulkan was installed. So while that's installing, this bit takes a while. So right now what's happening is we have downloaded and we are setting up the llama.cpp. And so this is making, and this takes a long time. So what we're going to talk about is why did you see Vulkan there? If you have a bit of background here, you might have thought, are we not going to use ROCm for AMD? And for certain modern cards, it is indeed better. Vulkan works on everything, put it simply. So for older cards, it is much easier to support just by using Vulkan. For old Intel, even old mobiles, and the inference performance that you do get, especially in cards like this, the 7900 XTX, it isn't that much difference. I've even seen people argue that it's better. Now, for modern cards, it does seem to be, without question, ROCm, especially when it comes to trying to use training, things like that. But this is purely focused on being as compatible as possible for as much hardware as possible. We will have a later video to show you how to supplant that, I suppose, with ROCm. Vulkan really being the backup if ROCm didn't work. For now, I just wanted to keep it really simple. If you're following our guide, of course, you could have went straight to ROCm, but you may not. You may have been using an older card. I don't have control on that, so I wanted to make sure that this would work for you as well. So that's really that. At this point, we're going to have a lot of watching. Because it didn't need to update the GPU drivers, we shouldn't need to restart, so we should be okay. But I'm basically just going to disappear, and we'll cue the time lapse again. So at this stage, looks like we might have an issue with the model downloads. I'm going to go and investigate the problem, and we'll see what we can do. So we're back. So we had a bit of a technical issue before where basically it wasn't an issue on our end. Hugging Face was either not updating us that the downloads were happening, or there's an issue in the CLI. But basically we were downloading the models, it just wasn't telling us that. So we panicked, we paused it, we tried to look into it, there's actually no issue. So I've let it continue, all the models are downloaded, but subsequently everything else is installed as well. So we're going to run the uninstall script to get us back to where we were before we started, run the install, but this time the models are already downloaded. So it'll just skip that bit. So we're going to just run this. Now, this is just telling you what it's going to keep. Everything big and everything the system needs, we're going to keep, as well as LACT, which is going to be to control the GPU power. So we're going to proceed. And this is very quick. I'm just going to remove all the services, uninstall everything, and we're done. And quite simply, we're going to run the install script. So this is exactly the same as before. Exactly the same options. We're just going to hit enter. Now, unfortunately, we do need to rebuild the llama.cpp port deployment, and that takes a wee bit of time. So we'll take this opportunity to actually discuss Odysseus, which is how we're going to interact with our models. So llama.cpp is going to be the inference engine we deploy that runs the actual model on your hardware. It has an API on your network, and you can then plug into that, in this case with Odysseus, or any other framework. Eventually, and personally I use it, we're going to start discussing using Hermes, which is an agent framework, and it can work directly on your hardware, and it will also use the local AI. So very quickly on the right-hand side, we're just going to look at Odysseus. This is a platform made by PewDiePie. You may have heard of it. It's fairly good. It has everything a beginner would need to get started. Works reliably. There's some minor bugs, but nothing to worry about for now. I would recommend have a look through. But this is the highlight. It's everything that you'll need really to start dipping into AI, test that your hardware is actually working, see some of the capabilities, and really just start playing around without wasting too much time, really. And that's what we're going to do. And the other thing that I'm going to show you now is LACT. So this is just going to build away in the background. Eventually, we will need to create our login for Odysseus. But LACT is the software we're going to use to actually power limit the GPU eventually and just monitor it in general. When this install finishes, you will get this software. Now you can control it programmatically, but I would just use the UI if it's handy. So right now what you're seeing is our GPU in action. There's not really too much going on. We're just installing. There isn't, any models deployed yet. But this is really where you want to sort of see what's the status, what's the temperatures, most importantly, are we healthy? And you can see the power usage here. Now this 7900 XTX, it's a 350 watt card. My instinct would tell me we can drop this to 250, maybe even 200 without suffering too much. You quite simply just do it here. Not going to do it for now. In fact, why not? Let's drop her down to 250. Now, actually, we can't with AMD. Now, the reason for this is AMD has a lot of hard caps where usually you can go between 10-20%. So this is actually going to limit us here. But that's enough for now. We'll apply. Do you want to keep the new settings? Of course we do. And this will apply over resets, which without going into it too much, there's specific APIs, NVIDIA SMI, ROCm SMI, I'm guessing, where you could control specific GPUs. LACT works for them all. This is something we'll do a dedicated video on eventually as well. You can create profiles if you had multiple GPUs, and overclocking as well. We're not enabling it now. We'll go into that another point. But basically anything you'd want to do in terms of your basic hardware control, not even basic actually, you can go quite deep, you can control from LACT. And so when this finishes installing, you will just simply have it in the corner like this. So I'm going to close that down because this is about to finish if my memory serves me right. If it's not so right, we'll speed it up a wee bit. But we'll very quickly set up our admin and our password for Odysseus. I'll demonstrate how it works, and that is us good to go. So I'm going to take this opportunity to briefly discuss services. And so when I first started getting into this, I set everything up. It was great. Turned off my rig and wasn't there the next day. Effectively, once you run the script, it'll deploy everything. But unless you set up a service, it's not going to restart if you turn off your hardware. So what the services do is effectively just run a small script. It's the same one that we have in our install script to just redeploy the services when the hardware starts again. So that way, if for whatever reason you had to restart, power cuts, you name it, everything will just spin back up and be available again downstream. And that's going to be true for llama.cpp, which is how we serve the model, and Odysseus as well, which will be how we interact with it, or at least we interact with it in the beginning. So right now you'll see it's asking us for our admin. This is our username. It's going to go Daniel, because it's my name, and then password, whatever you want, of course. Doesn't matter too much. So it'll finish a few final stages here, and I'll just quickly note that if you didn't have LACT installed, this is where it will install it. Fairly quick process. And then important, we should focus on this, is the firewall. Okay, so this is what opens it up onto your network and allows other devices to talk to it. Specifically though, you should note here, this is just local network. We're not doing anything external, we're keeping it local. Now that we're done, some summary stats. So the model server is here. It's on port 8020/V1. Now, if we go here, you won't see anything useful, but that's because we're not meant to be talking to it like this. But that's where any sort of services or downstream programs like Odysseus are going to interact with it from. Just some GPU status is good. We should be on Vulkan. If this was NVIDIA, it should be different, of course. Workspace, this is Odysseus. We'll go here in a little moment. This is our model directory. We have them here. Well, no, that's our script. Never mind. We have our models here. And connecting apps again, it's just reminding you that this here is going to be the endpoint you want to use. Now, if you want to check, is everything working correctly? Did my models download? It's the same endpoint with /models, and you'll see everything you've downloaded. The way that we have deployed llama.cpp is that it will look into this models directory, and effectively if it's here, it will use it. So if you want to add any more models, you simply download them into here, and they will automatically get detected. This is the benefit of taking this approach. There's some downsides. You don't get the native UI, but we're going to be using Odysseus anyway, so that's not too important. And again, just some brief instructions. Generally, I'd recommend Hugging Face. There's some other options. And again, if you're stuck, how to restart and some other things. So we're going to go straight to Odysseus. We're just going to wrap up fairly shortly here. And the goal is that you're going to play around with this for a bit. And in further videos, we're going to dial in how we run our models, how to use Odysseus, how to use Hermes, you name it, we're going to cover it. So port 7000. And this will be on your local network. So you want to look up your IP. So replace localhost with your IP, and then the port's the same. So your username and your password, we are not going to save, and we're in. So there's a lot of guides online about how to use Odysseus. I'd recommend checking them out in the interim. We're going to focus on one more to do with you've only got local, and some tailored to what we plan on doing with this project, but you'll have different goals, so do look into it. There's a lot of pretty cool features. If you want a quick sort of snapshot, pause the video now. This is what you can kind of do. Cookbook is very good for managing models. Again, I'm not going to go through it all in this one, but we've just started. How do we actually get our model into it? So settings, and right here at the top, got added models later for when we have them, but we quite simply want to scan, and it's found the server. We go into added models and you will see our server. So we have two models, just the two small models. If you go for the full set, you'll have bigger models that can run on the 24 gig card. But for brevity's sake, we're just going to use these. So it's kindly updated. We use the 4B, going to be fancy. You'll notice here Odysseus has web search. It was on, turn it off, turn it on. Pops up with a little info, and let's just do a test. Can you give me the weather in Belfast right now? Now, before I run this, I am just going to load up LACT. And we're going to get very close to what my workflow kind of actually looks like. I'm going to stick that in the corner here. I'm going to stick that in this corner here. This is over here. And so pay attention here to our GPU usage, our power usage, our VRAM. Because when we run this, the model should get loaded into memory. So you should see the VRAM usage increase, and you should see the power go up as well. And it's good. So the fact that we're processing results, we can already start to see some changes, and the model is loaded. And so what you're seeing right now in real time is the model loading, the weights getting put into memory, and then the prompt actually going in. So this first bit takes a little bit longer, and that's it, ready now. And so I'm not sure if the mic is catching up, or you can hear this. A little slight clicking, but not running too hard. GPU is at full utilization, but you'll notice the power. So we do want to utilize the GPU, but at what power, at what cost, so to speak. And so this is the Gemma E4B. It's a 4 billion parameter model, could run on a medium to powerful smartphone. And very basics, can you give me the weather? And that's about accurate. Feels a lot less. So that's really how to get started. Again, before you run the install script, please read it. Pass it into ChatGPT at least. Just I do not want to build the habit of running random scripts. However, given that this video series is targeted at new users, the script just makes your life a lot easier. I'm not sure if it'll be the next video. I've created a manual guide to effectively replicate every step manually. The problem with that is that it's quite long because it depends on your hardware. there's a lot of it depends. Now, I'll create a video for that. It'll be dedicated to just stepping through it. But it is irrelevant to actually getting started. The functionality we have in this script will be identical. So if you just want to get started, this is your place to go. So we went from fresh install of Linux. We now have LACT to monitor our power. We have llama.cpp running and deployed locally on our network to run the local models. And we have Odysseus to start interacting with it. Next steps are going to be to start diving into how does Odysseus work? What sort of models should we use? What's the tuning should we use? And what can we actually do with the hardware? A few models have come out since we started this project, the Gemma 12B in particular. I have a 2070 Super in the corner that I am quite excited to try, because in theory, some of the smaller quantized models should fit on that. If so, that brings the budget build down from just over £1,000 to £484, which half price is fairly good progress to the project. Because again, let's remember that the main goal of this project is to get local AI running, but with an affordable price tag and a quality that is acceptable. There's no point if it's £500 and we get absolute nonsense out. So again, thank you for checking in. Part 3 will probably be out in a few days, focusing on Odysseus. In the meantime, I just would recommend diving in, have a poke around. In particular, Cookbook is going to be your best friend if you're trying to work out what models can you run on your hardware. But we'll leave it at that. Thank you very much and hope you have a good night.